Hello and welcome to our video accompanying the Science 2.0 article for December. I'm Ben Smith here with Jared Mader, and we're going to talk about choosing a 3D printer. Now last month we looked at how you can use the design process and the ways that 3D printers fit in with that. And so what we're going to do this month is really talk a little bit more about the specifics when you go to choose a 3D printer. So we thought it might be a good idea to sort of review, for those of you that might not be familiar, briefly what 3D printing is and how it works. And so what I will start with is just telling you that 3D printing is becoming very commonplace. Adidas just recently announced that they're going to be 3D printing over 100,000 sneakers. And so you can sort of see like their types of machines, you'd be able to design it, and then you print out that sneaker. And another place that we see this happening is in manufacturing. We had talked with some folks down at NASA that when they would try and make a part that they might need for a satellite, that they would have to go and get that turned in their machine shop, and it would cost a lot of money to do that intricate work. And so this type of part that you see here on the screen, that's the type of part that they might get printed. Well, now you can save a lot of money by 3D printing and testing out those pieces. So rather than making like a mold, as you might see here, for a typical machine cost that's over $3,000 for a part, you can print it out for a lot less, a huge savings. They were talking about taking $100,000 parts and being able to design them for about 10% of that cost. So some of the vocabulary that you might want to be familiar with would include things like filament. That's the material that goes into the 3D printer. The extruder, which is where it comes out, and you can actually see this almost looks like a hot glue gun, and that's exactly what it is. The print bed, which is where the object will be printed on. STL files, those are the file name extension that we see, similar to what you might expect for a PowerPoint would be PPT, or a Word document might be .doc or docx. Well, for a 3D file, it would be .stl. And the way you design those files is using CAD software. Now, so what types of things can you print? Well, typically in classrooms, we're printing in some type of plastic. PLA and ABS, those are the acronyms we use for the most typical types of materials that get printed. So like PLA, it will not need a heated bed. It is a plastic, it's biodegradable, and one of the things you have to realize is that the melting point for that material is probably somewhere right around 200 degrees, and so that means that if you were going to use the object at a temperature greater than that, it probably won't work because it'll melt in that situation. But you can print in things like wood, metal, carbon fiber. There are all kinds of places that you can find that type of information. Now, the way a 3D printer works is that you have your filament back here. You have it being fed up through, like this is a tube that we might see where it would be fed through, and then you have your print head, and this is the hot end, this is the extruder, and it prints it out on top of the printer bed. So it really is, this is like the hot glue gun, this is just feeding the material into it. Now, we talk about 3D printing, it is additive printing material. That means that it lays down a layer, and so you can see what we're seeing is a very thin layer here, and then on top of that we have the next layer and the next layer, and so we're adding the material on as we go. So now that we've sort of gotten those pieces out of the way, let's jump and take a look at what we might do in the design piece. And we talked about Tinkercad a little bit last month, and so here's my work plane, and as I mentioned about the print bed makes a difference. So the printer that we use actually has a print size that is 4x6, and so I will edit my grid, and you can see it's set up in millimeters. I'm going to switch it over to inches, and I'm going to make it 6 inches wide with 4 inches high, and I update the grid, and now I have a work plane that actually matches my print bed size. So I know that when I drag a material out, that I wouldn't want to like go off the print bed as you see here, because that won't print, that won't work for it. And so it gives me that scaled perspective that I would need in looking at this object. And so I think that's really important. Now, so this is Tinkercad again, and remember what we said is you can export that file, and you can see when I highlight over it, it says download for 3D printing. So if I wanted to print this block, I can hit download, and what we typically work with are STL files. Now that you can send that STL file to the 3D printer. Now, some 3D printers do this on their own, but others need an additional piece of software that will take that 3D STL file and it will slice it. And what we use is software called Kyra, which is free cross-platform software that does the slicing. And here is where we can start to think about how or what type of printer we might choose. So you can go to Ultimaker, which makes this type of software available for folks. And if we take a look at Kyra, here I'm in Kyra, and I have already loaded in a set of wheels that I might want to print. And so you can see, like, we can maneuver it around, we can zoom in a little bit. But again, those are just 3 wheels or 6 wheels that we're going to print. So over on the right side, there's a whole slew of settings that we can work with. So first of all, it'll ask you what the material is, and in this case, it's PLA. ABS is another choice, and you can see some of the other ones that are listed there. In addition, you need a profile. Now, we happen to use the Mod T printer, and that's why I have that listed here, but you could choose your own printer and load that in where it says Manage Profiles. You would load it in for whatever 3D printer you have. And you can actually search for those printers right here as well. But I already have it loaded in, and it looks at these types of settings. So the quality, the shell, infill, material, speed, cooling, support, build plate adhesion, and special mode. So there's all these things that we can choose and adjust, and then when we're done, we'll hit Save to File, and that's going to save what's called a G-code file. And that G-code file is what a lot of 3D printers will take directly. Now, there's some other information that's really interesting down here, which is that because it knows which printer I'm using, it knows that those wheels are going to take 1 hour and 4 minutes, and they're going to print 20 grams of material, which is going to equal 6.94 meters in length from my filament roll. So you get a filament roll, typically we get either 500 grams or 1,000 grams, and so already we can start to think about what it might cost to print these materials. 20 grams, we could divide that into 1,000 grams or 500 grams, and we can figure out how many times we can conduct the same print. Now, as I adjust these, it will adjust those pieces. So when I overlay into one of the boxes, and right now you can see the layer height set at 0.3 millimeters. And it gives you the information on the screen about what it may affect. Well, the layer height is, if I jump back quickly over here, think about these little pieces here, as how thick that will be before the print head raises up and goes to the next level. So what would happen if I were to change that to 0.2? If I change it to 0.2, it will take longer to print because the layers are different, and it's going to take a little bit more material. And so Kyra will automatically update those settings. Then we can start to think about things like the wall thickness and how thick we want it to be, and adjusting that. The infill material, so the interior in the wall, so inside the walls, the walls don't necessarily print as a full thickness. Right now they're being printed at 15% thickness, and so that's the infill piece of that we could consider. For the material, this talks about the printing temperature, and you can see that's going to be tied into your printer, and the diameter of the filament. And so it's really important if you were purchasing filament to make sure that you have the right size diameter for it. Ours, and the most typical that we see in sort of the low-end printers is 1.75 millimeters. You can also adjust how fast it's going to print. And so, if it prints at a faster speed, so as it's laying down the material, and the travel speed when it's just moving the print head, it's actually a little bit faster. So you can adjust those types of things as well. And then we just move through the other settings. This allows us to get a lot of important information, and we actually conduct a competition with our students where we bring them in and we tell them they have 1 hour to design according to our challenge and 3 hours to print. Well, if you're starting to get students to think about the process that they're going to go through, this is an invaluable tool for figuring that out so that they can start to figure out, okay, well, I have this material and now I'm going to try and get it to print, and I can make those adjustments so they can print within that 3 hour block of time that we have for them. So when you go to go purchase a printer, we just saw it with the recent Black Friday sales that there's a lot of printers on the market, even $200 printers that are really top quality for the classroom in most cases. And so it's a great time to be thinking about purchasing one of those in this month as we lead up to the holiday season, as to what you may be able to get for a printer as they go on sale. But again, you want to just think about what those types of materials might allow you to do and what the reason you would want to use it for. And so with that, we'll go back to the essentials of 3D printing. I want to thank Jared for all of his contributions here as he's making sure that I'm telling you the right things standing behind me. And next month, we'll be looking at drones and how we might be able to start incorporating drones into our work in the area of science.
Thanks, everybody.